Good afternoon. Now we're gonna continue with module 2 as we did the beams this morning. We're gonna continue with module 2 because we did the beams this morning. Okay. Now let me share my screen so we can see what module 2 is all about. Module 2 is all about moments. So we do moments on levers, moments on beams, and moments on lamina. So we've done moments on beams. We are now going to do moments on lamina, which is right below moments on beams. Okay. So two things we're going to be required to do: to calculate the unknown force as well as the reaction force. How will we calculate the unknown force? We will take moments. Now, to take moments, you just need a force to be perpendicular to the distance. Then you are ready to take moments. For instance, this force is perpendicular to that distance. We can take moments. But if a force is not perpendicular to the distance, as in this case, we're going to need to resolve that force first. Say here, force F is not perpendicular to distance R. We're going to need a perpendicular component and a parallel component. And then for force F over here, we are ready to take moments. But in this case, we are not, because this force is not perpendicular to the distance. It's making 30 degrees. So we will resolve it to a parallel component and a perpendicular component. So in N2, we learned how to do this. In N2, we will do a triangle like that. Okay. And then secondly, we're gonna need to calculate a reaction force. So it's an unknown force and a reaction force. What is a reaction force? It's that single force that will bring balance to the system of forces. Third law of Newton says for every action, there is an equal but opposite reaction. So for every action, there will be a reaction force. Now, a reaction force is calculated the same way we calculate the resultant force. It will just be in the opposite direction. If you look at this example, here we have 20 newtons west, 30 newtons east. A resultant will be 10 newtons east, but a reaction force will be 10 newtons west. In this case, if you have a vertical force and a horizontal force, you cannot just add them. You will use the Pythagoras theorem because you have a right angle triangle here. So you will use Pythagoras theorem to say the square of the y force and the square of the x force. That will be northeast, but the reaction force will take the opposite direction, which is southwest. In a case like this, you will find the one force that represents your vertical forces, the one force that represents your horizontal forces. And once you get that, it's going to give you the magnitude of your resultant, and then your reaction force will be the same magnitude, just in the opposite direction. Okay, so let's go back just to summarize what we have discussed. To calculate an unknown force, you take moments. Just make sure that each force is perpendicular to a distance, then you are ready to take moments. To calculate a reaction force, you need to find the one vertical force and the one horizontal force. Those two forces, you use a Pythagoras theorem to get their resultant. Okay, so this means to calculate the resultant, the reaction force, you need to reference all your forces with the true vertical and the true horizontal. And to calculate your moments, you just need the force to be perpendicular to the distance. It does not have to be vertical or horizontal. Okay, now let's look at this example. Let's look at this example. This example is taken from the activity 2.2 of the prescribed textbook. This textbook, activity 3.2, 2.1 of this prescribed textbook, it's number 6 there. So it reads, calculate the magnitude of force P, this force P, as well as the reaction at O when the crank lever is in equilibrium. So it tells us that there is a reaction force at O. Okay, so we're gonna calculate the magnitude and the direction of that force as well. So we have question A, question B, and question C. Question A says, do this when the angle is 90 degrees, that angle. So if it's 90 degrees, it's gonna look like this, okay? Then to calculate, we will take moments. Clockwise moments are equal to anti-clockwise moments. Clockwise, we will have 80 times 0.6. Anti-clockwise, we will have P times 0.3. So to get P, we will divide by 0.3 both sides. So P is gonna be 80 times 0.6 all divided by 0.3 is 160 newtons. Okay. Now we are done with calculating force P. We know that force P is 160. The next thing we want to do now is to calculate the reaction force. To calculate the reaction force, we need to reference all our forces by the true vertical and the true horizontal. So that means we must figure out how far is force P from the vertical or the horizontal. To do that, we can use this right angle triangle that has just appeared here. This will be 30 degrees because that is 150. 150 and 30 gives us 80, and it's going to make that one 60 degrees. So we're going to resolve force P is going to have a perpendicular component as well as a parallel component. Perpendicular component goes down, parallel component goes west. It follows the direction of the given force. So this component is going to be P cos 60, and that component is going to be P sine 60. Okay. So now we want to know what is the magnitude and the direction of the force at O. So we're going to find the X force as well as the Y force. So that is the Y force, that is the X force. You can start with the Y force. Vertical components, upward forces are positive, downward forces are negative. Upward, we don't have a force. Downwards, we have P sine, but it's negative because it's downward. P sine 60 minus 80 minus 80 only. But P was calculated to be 160. So this is going to be 160 sine 60 minus 80. Let's see, 160 sine 60 minus 80. It gives us minus 218,564 newtons. That is the resultant force. A reaction force is going to be positive 218,564 newtons, and we're going to say it's going north. So that one was negative, it was going south. Then let's continue some of the horizontal components. Your eastwards forces are positive, your westwards forces are negative. Eastwards, who do we have? We have 0. Westwards, we have P cos 60. So we already calculated P, it came as 160. So we're going to substitute it there, 160 cos 60. So that gives us 80 newtons. So it's negative 80 newtons. That means it's going west. So our reaction force will be a positive 80 newtons going east. And then we calculate the reaction force using our Y force squared and our X force squared. Our Y force is 218,564. Square that, our X force is 80, we square that. So this gives us 218,564 squared plus 80 squared. It gives us 232,745 newtons. And then to calculate an angle, let's just resketch it because it told us that the y must go north and the x must go east. So it means the reaction force is there. So this is the angle that we will calculate. To calculate that angle, we will say tan theta equals to opposite over adjacent. Therefore, theta will be, we know that opposite, the y is 218.564 and the x is 18. Okay. So second function, 10 y 218,564 divide by 18. It gives us an angle of 69,896 degrees. Okay. So that is north of east. Okay. So that is how we would calculate when that angle was 90. So let's see now how different is it gonna be when that angle is 30. So as soon as that angle is 30, it means now we're not ready to take moments. We must first resolve that force because that force is now 30 degrees to the 0.6. It's not perpendicular anymore. So we must resolve that force. It's gonna have a parallel component and a perpendicular component. Parallel component will be 80 cos 30, and that one will be 80 sine 30. Now, this is just to take moments. Some of the clockwise moments are equal to some of the anti-clockwise moments. Clockwise, we have 80 sine 30 times by 0.6. Anti-clockwise, we have P times by 0.3. This one is still perpendicular, so we won't need to resolve it. Divide by 0.3 both sides to get P. So P is gonna be 80 sine 30 times by 0.6 all divided by 0.3. It's 80 newtons. Now that we have found P, we're going to do the same thing. We're going to resolve force P to see how far is it from the horizontal and from the vertical. This is again 30, that's 60. So we're going to have a parallel component and a perpendicular component. So this component is going to be P sine 60. And this component is P cos 60. So this is now to calculate the reaction at O. So again, we have a Y force here and an X force. So we want to know what is this Y force and what is that X force. Sum of the vertical components, upward forces are positive and downward forces are negative. Upward, we have nothing. Downward, we have P sine 60 and that one, 18 sine 30. So this is gonna give us P is 80 sine 60 minus 80 sine 30. 80 sine 60 minus 80 sine 30. Right, so 80 sine 60 minus 80 sine 30. Minus 109. Minus 109,282 newtons. So this means the Y force will be a positive 109,282 newtons, meaning it's gonna go north. Then to get the X force, we're gonna say sum of the horizontal components are equal to east is positive. There we've got east, 80 cos 30. West is negative B cos 60. This force and that force. Let's just substitute B cos 30. P is 80, so it's going to be 80 cos 60. Why is it jamming the whole time? So this will be 80 cos 30 minus 80 cos 60. It gives us 78,784 newtons. Let's just double check it. 80 cos 30 minus 80 cos 60. 80 cos 30 minus 80 cos 60. Double check. 80 cos 30 minus 80 cos 60. It's a positive 29. It's a positive 29,282. Okay, 29,282. All right. So it came as a positive already. It means it must go east. And then the X force must be negative 29,282. It must go west. Okay. So the X force is going west and the Y force is going north. So the resultant reaction is going like that. So our reaction force is going to be the square root of the Y force plus the X force, which is the 109,282, square that, plus the 29,282, we square that as well. That will give us 109,282 squared plus 29,282 squared. It gives us 113,137 newtons. And then the angle will be tan theta equals to the Y force over X force. So theta will be second function, the Y force, which is 109,282 over the X force, which is 29,282. It gives us 75 degrees. 75 degrees, okay? So it gives us 75 degrees. So that is how you will calculate. And if when the angle is 120, you simply gonna sketch your 18, make this angle 120, sketch your 80 Newton force there. So then your component will go this way and the other one will go that way. This will be, you will now use this angle. You will use that angle, which is 180 minus 120, it's 60. You will use that angle. So this will be 80 cos 60. And that one will be 80 sine 60. Just work it out and see if you get the answer for C. So the answer for C must be 138 for B, 218 for the reaction force, and 60 degrees. All right, thank you.